Hey everyone, in this video we'll learn how to do a sequence of transformations on a function. So in the previous video we've learned how to transform a function. We've learned about various types of transformations such as shifts, reflections, and stretches and compressions. And today we're going to put it all together. We're going to do multiple transformations on one function. So as you can see right here, we have this function graphed, f of x equals radical x, and this is what it looks like on the graph, f of x in blue. So we're going to perform 3 transformations on f of x. The first thing we're going to do is we're going to shift it to the right by 3, and then the second thing we're going to do is we're going to shift it down by 2, and the last thing we'll do is we are going to reflect over the x-axis, over x-axis. So these are the 3 transformations we're going to do on f of x equals radical x. So let's start with this one, shifting to the right by 3. So to shift to the right by 3, that would just be f of x minus 3. So f of x minus 3, let's go ahead and figure that out. What is f of x minus 3? So f of x minus 3, let's write it down here. So we know that f of x is radical x. So that means f of x minus 3 is radical x minus 3. So there we go. So far, our function is radical x minus 3. So radical x minus 3. Perfect. And the next thing we're going to do is we are going to shift this function down by 2. So we're going to take the function that we had from the first step, radical x minus 3, and we are going to shift it down by 2. So how do we shift a function down by 2? Well, it would just be the function that we have minus 2. So the whole function minus 2. So this function right here that we had from the first step, that's what we're going to write. So the new function now is radical x minus 3 and then minus 2 outside of the radical. So radical x minus 3 all within the radical, and then minus 2 is outside the radical. Perfect. And then the last step is we're going to reflect this over the x-axis. So how do we reflect this function over the x-axis? So to reflect a function over the x-axis, it is simply just negative the function. So negative the function of x. So that means we're going to put a negative in front of this function from step 2. So we're going to put a negative sign in front of the entire function from step 2, and we're going to put the entire function in parentheses. So the square root of x minus 3 minus 2, and we have a negative outside of a parentheses here, so we're going to have to distribute it here and here. So distributing this negative, let's go ahead and scroll down. So to distribute this negative to radical x minus 3, that comes out to negative radical x minus 3. And then to distribute the negative to negative 2 actually. So a negative of negative 2, that just flips the sign. It becomes positive 2. And there we go. Let's call this function g of x. We have performed all 3 transformations on g of x. We have performed the first one, shifting to the right by 3. Then we have shifted down by 2. And then we reflected it over the x-axis, a vertical reflection. Perfect. So we have this new function, g of x equals negative radical x minus 3 plus 2. So what does that look like? Well, let's go ahead and just do each step. So in this first step, we had radical x minus 3. So radical x is this one in blue. So radical x minus 3 would just be the blue one pushed to the right by 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. We're just shifting every point to the right by 3, and 1, 2, 3. So this orange one is step 1. Good, so that's step 1. And then step 2 was we shifted down by 2. So we're shifting radical x minus 3 down by 2. So we're going to shift the orange function down by 2. So we'll start here, and we're going to go down 2. So 1, 2, 1, 2, 1, 2, 1, 2. And let's go draw that. So the green function is step 2. So we have the red, we have the green, orange. So we have blue, orange, green, and then the last one we'll do red. So reflecting over the x-axis we'll do in red. So we'll do that in red. So reflecting this over the x-axis, we put a negative in front of the green function. So we had the green function, which was radical x minus 3 minus 2. And then we put a negative in front of it to come up with negative radical x minus 3 plus 2. So the third step, the third and final step of this transformation, is reflecting this green function over the x-axis. So the x-axis is right here. And we are going to reflect this green function over the x-axis. So how does that work? Well, let's start with this first point. So what is this point? This point right here is 3 comma negative 2. All you're going to do to reflect it over the x-axis, you're going to change the sign of the y-coordinate. So this becomes 3 comma 2. So 3 comma negative 2 becomes 3 comma 2, which is here. And then we're going to do that for every point. So we're going to flip the sign of the y-coordinate. So this is 4 comma 1, 4 comma negative 1 right here. 4 comma negative 1 will become 4 comma 1. 7 comma 0 will still be 7 comma 0 because flipping 0 to the negative version, it still comes out to 0. And then over here, this is 12 comma 1. That will become 12 comma negative 1. And there we go. So the red function is step 3, which is our g of x, which we have here, g of x equals negative radical x minus 3 plus 2. So we started with the blue function right here. And after a sequence of 3 transformations, we shifted to the right by 3, we went down by 2, and we reflected it over the x-axis. After doing all that, we came up with the red function right here. And that's how we do a sequence of transformations on a function. We just do them one after another. We take the result from the prior step, and then we do a transformation on that. So like, for example, after we shifted the function to the right by 3, then to make the function go down by 2, we took the function from the previous step. After shifting it by 3, we put it here. And then we shifted that entire thing down by 2. And then after we came up with this result, we went ahead and reflected it over the x-axis by putting a negative in front of it. So that's how you do a sequence of transformations on a function. So one more thing that's very important to mention is the order in which you do this sequence of transformations matters. It matters which order you do it in. First, we did shift to the right by 3, and then we shifted down by 2, and then we reflected across the x-axis. That order matters. Let's say we did it backwards. So let's go ahead and actually do this whole thing backwards. So let me go ahead and get rid of the orange, red, and green functions. And let's go ahead and just do it backwards, just to show you how different it would come out. Or actually, let's go ahead and just put that all back. And let's actually, so we can see the difference, let's go ahead and just draw it on another graph. So we have this, and then this. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9, 10. 1, 2, 3, 4, 5, 6, 7. -1, -2, -3. -1, -2, -3, -4, -5. And then we'll go ahead and draw f of x again. So 1, 1, 4, 2, 9, 3. Let's try that again. There we go. So that's f of x equals radical x. And let's go ahead and do this sequence of transformation backwards. So we are first going to reflect across the x-axis. So our first step will be the last step in the last problem. So reflect across x-axis. And then we are going to shift down by 2. So we're going to shift down by 2. And then we're going to shift to the right by 3. And shift to the right by 3. Okay, so the first step, reflecting across the x-axis. So step 1. How do we do that to f of x? All we have to do is do negative f of x. That will reflect it across the x-axis. So what's negative f of x? Well, we know f of x is radical x. So to substitute this comes out to negative radical x. So negative radical x is what we have so far. And then if we went ahead and graphed it, then negative radical x, all we have to do is take each point and change the sign of the y-coordinate, similar to what we did above. So 0, 0 would stay 0, 0. 1, 1 would be 1, -1. 4, 2 would be 4, -2. And 9, 3 would be 9, -3. So that is the result of the first step. And now from this point, we did the first step. We have negative radical x. So the second step is to shift down by 2. That's what we want to do. So how do we shift a function down by 2? We take the function of x, and we're just going to subtract by 2. So what was the function that we had in the last problem, or the last step? We had negative radical x. So let's write that. The function from the last step was negative radical x minus 2 on the outside. So negative radical x minus 2. So how do we graph that here? We are just going to shift every point down by 2. Let me actually go ahead and extend this so we have a little more space. -7. So we're going to take the red from step 1. We're going to shift every point down by 2. So 0, 0 becomes 0, -2. 1, -1 will go down by 2 to 1, -3. This will go down by 2. This will go down by 2. And there we go. Let's connect the points. So the red was step 1, and the green is step 2. Perfect. We're almost there. Now we have step 3. So for step 3, we're going to shift to the right by 3. How do we shift to the right by 3? That is the function of x minus 3. So what is our function from the last step? It's negative radical x minus 2. So the function of x minus 3, this would be, let me just write it like this in this color. So negative radical x minus 3 minus 2, just so you see the difference. So we have negative radical x minus 2 on the outside. So the function of x minus 3 would be negative radical x minus 3, then minus 2. So that shifts it 3 spaces to the right. So this new function, which we'll call g of x, radical x of negative radical x minus 3, then minus 2. So we are just going to shift the green function up here, and let's draw that in orange. So we're going to shift the green function up here 3 spaces to the right. So let's start at this point, 0 comma negative 2. So this becomes 3 comma negative 2. 1 comma negative 3 becomes 4 comma negative 3. And this will go to the right 3 times, 1, 2, 3. And then 1, 2, 3. There we go. So this orange function right here, this is the third step, and the third and final step. And going from, we started with the blue function, f of x equals radical x. And through this series of transformations, we ended up with the orange function. So compare it to what we had above. Our first step was this blue function. So both of them started in the same place. We both started with the same blue function in the first graph and in the second graph. But for the third step, the very last step in red here, we have this function in red, the one in red. And then down here, we have the last step is green. We have this function in green. So it's very different than the red function up here. So that's why the order in which you do the sequence matters. So that's because first we shifted to the right by 3, then we shifted down by 2, and then we reflected over the x-axis. Because we reversed that in the second graph, first we reflected across the x-axis, then we went down 2, then shifted to the right by 3. We did the same steps, but in a different order. So that's why we got a different result at the end, a different transformed function. So the order in which you do it matters. So I hope this video helps to understand the sequence of transformations on a function. And if you have any questions, please leave them down in the comments below, and thank you for watching.